All right, that produces least amount of products, right? Said Muhammad is here. Let me enter him in the class. All right, so limiting reactant can be defined as the reactant that produces least amount of products, or the reactant that consumes earlier in the chemical reaction, or the reactant whose consumption result in the stopping or result in the completion of reaction. Result in the completion of the reaction, right? Completion of the reaction. Now let me give you an example to you people. Okay, look at here. For example, we have a container, right? Having, let's assume we have given that example to class 11th and 10th as well. So also giving you the same example. For example, we have 5 triangles, right? And also we have, for example, 8 circles, right? And as a rule, we know that one triangle will reacting with one triangle to form only one product, right? To form only one product. So what will happen over here, after the reaction, one triangle will be going to react with one circle to form product. Same is the case with another circle is going to react with another triangle. Same is the case for other triangles as well. One triangle will be going to react with one circle, right? Now the reaction will stop. Although we have around 3 more circles left that remain unreacted at the end of reaction, right? That remain in excess or non-limiting. But the reaction has stopped because the triangles have been consumed. So can we say that it is limiting reactant? The triangle is the limiting object, right? And this one is non-limiting because it is still present after the reaction, right? So we can say that the reactant, the triangles that produces least amount of products, like the circle has to make the products, it may have made 8 number of products, but as there are limited number of triangles, so the final product formed will be in accordance with the number of triangles present. As there are only 5 triangles present, so the number of products finally found will be 5. In other words, the reactant that consumes earlier in the chemical reaction, right? Now, which one has been earlier been consumed? Of course, triangles have been earlier consumed. Same is the case with the third definition, whose consumption result in the completion of reaction or stoppage of the reaction, right? Like all the triangles have been consumed, the reaction has now been stopped, or reaction has now been completed. Now, according to chemistry, for example, we are going to take an example of hydrogen. Example, we have these hydrogen molecules, 4 hydrogen molecules, right? And same is the case with we have 3 oxygen molecules, right? We know that the structural formula of the structure of water is H2O, right? For each oxygen atom, we need 2 hydrogen atoms, right? For each oxygen atoms, we need 2 hydrogen atoms. So as there are 8 hydrogen atoms, so only 4 water molecules will be formed. Now hydrogens have been consumed, although oxygen is still present in the container. But as all the hydrogens have been consumed, so the reaction will now become stopped, right? The reaction will be stopped. Is it clear? And it is the hydrogen that controls the amount of product form, or it is the hydrogen that how many number of molecules of water must be formed. So we can say that the hydrogen is limiting reactant and the oxygen is non-limiting or the excess reagent. No, is it clear, dear students? Saleh Shah?
Sir, can you
Yes,
please
sir.
explain?
Sir,
Yes, please.
sir, is this the only thing that you since the beginning of the lesson because I joined late?
Yes, this is just the definition. Let me revise it for you again. But actual thing is that of numerical problems. This is just a concept, the basic concept of that what is limiting reactant, right? I'm just giving you an overview, and also I'm revising it again. So basically, limiting reactant is a reactant that produces least amount of products. Like we have taken a DILDAF example, a simple diagrammatic example, and chemistry example. For example, we have 5 triangles and 8 circles, and we know the rule, we know the reaction that one triangle will need 1x to make a product, right? So as there are 5 triangles and there are 8 circles, so 5 triangles will attack on 5 circles to form 5 products, right? And as soon as triangles are completely consumed, the reaction will stop. Such type of reactant whose consumption result in the stoppage of reaction is called as limiting reactant. As the circles have been left unreacted at the end of chemical reaction, so this one will be non-limiting or excess reactant. Same is the case with hydrogen reacting with oxygen. As there are 4 molecules, or in other words 8 atoms of hydrogen, right? So as soon as 8 atoms of hydrogen are consumed, like in this case, right, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5, 6, 7, and 8, right? Now as the reaction have been the all the hydrogen atoms have been consumed, so reaction will stop, although oxygen are still present, still available in the container in the reaction, right? But the total number of product has been decided by the hydrogen, so that's why hydrogen is limiting reactant. Is it clear now? Every student please respond me, so that I move towards our numerical problem.
Yes, sir.
Is the basic concept clear to everybody? Shabash among boys. Okay, our actual today's actual topic is, of course, the, I'm sorry about that, the numerical problems, right? You'll have to just read these points, and you will get much more clear. So let me open my electronic whiteboard, which is over here. Okay, this is the question, that sodium reacts with sulfur to form sodium sulfide. Sodium, 2 moles of sodium in solid form reacts with 1 mole of sulfur in solid form to form sodium sulfide, whose formula is Na2S. Okay, they are asking that you have 9.2 grams of sodium. All right, we are good to go. And 8 grams of sulfur. All right, we are good to go. And they are collectively reacting together to form sodium sulfide. Okay, they are asking that which reactant must be in excess and which reactant is the limiting reactant. Now how are we going to find these two? Let me clear your concept. Is everyone here, right? And also everyone, now we are going to just conceptually, in order to clear our concept, we are dividing this solution into 2 portions, right? One will be for sodium and one will be for sulfur. First of all, we are going to compare, first of all, we will be comparing sodium with sodium sulfide, and then sulfur with sodium sulfide, right? How? Look at here. Look at the screen, please. We are discussing in pretty much detail. They have given 9.2 grams of sodium. All right, we know 9.0 gram of sodium. So first of all, as we know that for mole calculation, we need, sorry, for ratio calculation, we need number of moles for both reactants, right? So we know the formula and we have practiced this formula a lot. So number of moles is equals to mass in gram divided by molar mass, and molar mass of sodium is 23. Now please calculate it down. Hurry up, within no time. Hurry up. Anybody?
So wasn't it 9.2 grams?
No, just be confirmed, be sure.
Sir, no, in the calculation you wrote 9 grams. It's 9.2 grams.
9.2. All right. Excellent. Excellent student, dear student. I'm sorry about that. You'll have to, yes, 9.2 grams. Now divide it. What is the answer, please? I
Sir,
want you
zero point
to
0.4.
point for, I want you to practice calculations. Although I have calculator, but I want you to do it for me. So number of moles are zero point 0.4, right? So in the next step, we are going to compare sodium with sodium sulfide, right? This is given data, this is required data, better. So as we have discussed yesterday, that according to the balanced chemical equation, 2 moles of sodium react together to form 1 mole of sodium sulfide. Now, the next step is that of given data. We have 0.4 moles of sodium that will form X. So just cross multiplication. X into 2 is equal to 0.4, or X is equal to 2 will be divided by 0.4, then it will be equal to 0.2 moles, right? So it means we have calculated zero point 0.2 moles of sodium sulfide formed from 0.4 moles of sodium, right? Now we are going to convert this sodium sulfide into mass in gram, and you know formula much better, and that is number of mole multiplied by molar mass, right? So mass in gram is equal to number of moles are 0.2, and molar mass of sodium sulfide, let's calculate it. 23 multiplied by 2 plus sulfur is 32, so 46 plus 32, that will be equal to 78 grams per mole. Okay, we are going to multiply it with 78 gram per mole. So what will be the answer, please? Just do it. Hurry up, boys and girls. Hurry up.
Sir,
Don't be late, please.
what is
Yes.
78 point?
What?
Sir, what did you write? 78 or
It is
78.8?
78. 78, just 78 grams per mole. This is 78, right? The molar of sodium sulfide is 78. 78, right? So just multiply 78 by 0.2. Please just do it.
15.6.
Yes, 15.6. Now, again, in the next step, we are going to compare sulfur with sodium sulfide. That one, the mass of sulfur was 8. So first of all, we are going to calculate number of moles, right? And the molar mass of sulfur is 32. So what will be the answer, please? Hurry up. Hurry up, boys and girls.
5.
Okay,
Sir,
so
0.25.
excellent. Thank you. Now, again, we are going to compare sulfur with sodium sulfide, right? We know that according to the balanced chemical equation, 1 mole of sulfur reacts with sodium to form 1 mole of sodium sulfide. So of course, 0.25 moles of sulfur will react with sodium to form the same number of moles, okay, of sodium sulfide. So what we are going to do, we are going again to convert this number of moles into mass in gram as we did in previous step. So number of moles multiplied by its molar mass, number of moles is 0.25, and its molar mass was 78. So what is the answer, please? Hurry up. Hurry up, students.
Sir, into 78 is 19.5.
Yes, excellent. So look at here. Sodium is producing 15.6 grams of sodium sulfide, right? And sulfur is producing 19.5 grams of product. So according to the definition, according to our definition that we have just learned, which is going to be the limiting reactant?
Sodium.
Yes. Why? Because it is
Sodium.
producing least amount of product, least number of product. So this one is called as limiting reactant, and the sulfur will be non-limiting reactant. Is it clear, dear students?
Yes.
Excellent, excellent. Now again, so the reactant that produces least amount of products, right? That is called as limiting reactant. Okay, we are heading towards our examples. This one you will be starting
But I
from.
think
Yes, please. Yes, yes.
the class.
Next class kiski. All right, all right. So just practice these worksheets, worksheet number 8 and worksheet number 10. And if there is any confusion, you can tell me. All right. Okay. Okay, dear students.
Yes, sir.
Yes, please.
Can talk to you at the end of the meeting?
Yes, of course. Why not? Okay. My camera, do you want to discuss over here?
I can discuss it over here.
All right. Just it. Rest of you can leave the class. Okay, let me stop
Yes,
that
sir.
recording. Yes, please.
Could you send me the